Welcome to the dsm-firmenich World Mycotoxin Survey. My name is Anneliese Müller and I'm a technical expert for mycotoxins. In this short video, I want to have a look with you on the mycotoxin risk in swine production based on the samples we analyzed between January and December 2024. So let's get started. First, I want to have a look at all of the finished feed swine samples globally collected in 2024 and analyzed for the 6 main mycotoxins. You can see here the prevalence. Cerelanone is most frequently found in 80% of the samples, followed by DON and fumonisins in 61% of the samples. Also, AFLA, T2 toxin, and OTA are quite abundant. If we look at the average concentrations in ppb, we can see fumonisins quite moderate. Deoxynivalenol levels increased with over 460 ppb and a super high maximum. SEN levels rather moderate, and AFLA values increased with 7 ppb, which would be in EU regulation already too high for feed for piglets. Now, if we look at all of the samples analyzed for more than one mycotoxin, we can also see that 87% of those samples also contain more than one mycotoxin, so co-occurrence is really high. What are the effects in the animals? It's well known for aflatoxins, carcinogenicity, immune suppression. It can lead to pale liver syndrome. Cerelanone affects the reproductive system, can lead to swollen vulva, reddened teats, prolapse or splay legs. Ochratoxin A affects the kidney and the liver, and the carryover to pork meat is possible. Ergot alkaloids can lead to necrosis due to vasoconstriction effect. The big group of triglycerides, such as DON and T2 toxin, show dermal lesions, vomiting, gastrointestinal tract is affected, the immune system is affected, and also fumonisins affect the gastrointestinal tract, the immune system, and they lead to respiratory problems, pulmonary edema. Now, such clinical effects as on the pictures are rarely observed in the field and occur at very high concentrations. Mycotoxins still have a high impact on animals. Even though we don't see clinical signs, there are several studies which indicate the effects which show the effects on the intestinal gut barrier and the increased susceptibility to disease in the presence of mycotoxins. So they decrease firstly the barrier function. Here a study with fumonisins, another study with fumonisins showing that the E. coli translocation over the gut barrier is increased when fumonisins are present. Here, deoxynivalenol induces histomorphological changes in the piglet, such as villi fusion, and fumonisins, as example, have been shown to be a predisposing factor for pneumonitis caused by Pasteurella. So if animals are exposed to fumonisins and Pasteurella, the rate of pneumonitis and coughing goes highly up. Now, when we look at results of the spectrum top 50 analysis, which includes emerging mycotoxins, we can see most frequently found eniatines in 85, 84, 73% of the samples, and also bovaricin, very frequently found. And for those two, I want to point out 2 in-house studies that we have. The one is an in vitro study with intestinal porcine epithelial cells. Here, the effect on the gut barrier was studied, and it was found that eniatines and bovaricin significantly reduced the gut barrier function, and an increased synergistic effect with deoxynivalenol has been shown. And one first in vivo study showed effects of eniatines, bovaricin, and DON on weaning piglets. So if eniatines and bovaricin and DON were present, decreased body weight gain was observed. When eniatines and bovaricin with DON were present, we saw that the villi height was decreased. Eniatines and bovaricin also alone increased the liver lesions, and emerging mycotoxins reduced the diversity of the gut microbiome. So what is important to keep in mind, we don't know so much about emerging mycotoxins, so studies are done with high concentrations that we usually don't observe like this in the field. With this, I want to thank you for your attention. To learn more about the mycotoxin survey, please visit our website.